Hi, welcome to the breadboard. In this episode, we're going to be assembling the Z drive components for our Voron build. In the previous episode, we had finished assembling the basic frame. What we're going to do in this episode is start putting together the Z components that are needed as part of the next step. Now, what we're going to do today is we're going to assemble these Z idler pulleys that you can see up the top here on this diagram. 1, 2, 3, 4, one in each corner. There's two main parts of 3D printed material for this. I'll show closer up views of those, and also assembling the motor and gearbox units that go on the bottom of the printer and provide a little bit of rubber feet and things as well. One thing that I had to do, which I cut out from an old piece of aluminum that I had, was create this separator. There is a diagram in the Voron GitHub site that you can download if you want to build your own. The other side I've left bare aluminum because I want to use it for a heatsink when we are putting in electronic components and things like that. For this episode, we're going to be doing these 3D printed parts at the bottom and on the top. We're building these Z idlers. They call them EYE lures because when they designed them, they put little eye type looking things on the 3D print. Purely cosmetic, no functional bearing except to make you smile. And we're going to be building the Z0 through 3 drive units that go underneath. Remember, this is a floating gantry, so there are 4 Z drives, one in each corner, that will move the nozzle with its gantry up and down throughout the range. So let's go down here. Okay, so putting in the deck panel, you will notice that there is a notch to it that determines the back of the panel. Now when you get the PDF, it actually only has 2 of these holes marked for mounting to the cross members, but you actually need to do 4. I found that out the hard way when I thought I was all done, and discovered, well, that doesn't look quite right. So I had a look at the picture as opposed to the PDF design sheet, and I found that there were actually 4 on it. This one also has a round hole in the middle, whereas the PDF has a square hole, so consequently I have a square hole. DIN rails, these are for mounting a lot of the electronic components. Nothing really much to those. You have to cut them to length, screw through into T-nuts that are mounted in the cross members, and that's pretty much it. And so for preparation for those gearboxes, we have some 3D printed ABS parts. Now these don't necessarily have to be ABS because they're not in the heated build volume, so potentially you could make them out of PETG. Either way, they want to be able to be nice and strong. They are going to take some tension from the 9mm belts they're going to be running up to the idlers. You need to print these. We need to put some heat set inserts to them so that we can assemble them properly, and we've got to assemble some gear shafts as well. So let's just quickly go to the overhead view and look at some of the components we have. I have a couple that have been pre-assembled at the end here. So what we have here is the gearbox. This is in my case, I printed it out of PETG because it's not in the build volume. I've already set the heat set inserts into here. There's 6 on the one face. There are 3 that go on the top here, and that's pretty much it. So 6, 7, 8, 9 heat set inserts onto this. The other part that we're going to be assembling is the top idler. Now this comes in 2 parts. You can do it in accent colors if you like. I've done mine in white and red ABS. And this is for the top idler pulley for the 9mm belt. This is what we're going to try and get to, is these 3 parts, where we've got the gearbox, we have the top idler, and we have the motor mount. Motor mount consists of 3 parts. Obviously the stepper motor, we have the mount, and we have a tensioning lever here, which is used to tension the belt gear wheel, which is in here. This needs to be mounted in a certain way, as you can see here. When you put this together, finally, you should probably put a little bit of Loctite as well. But it's a thread locker blue. Now the components that we've got, I've got them all separated over this side. These two I've got the main drives pre-assembled. So we've got the two 3D printed parts, these match together. We have a 9mm GT20 pulley, which is where the 9mm belt will go from top to bottom. We have a 80 tooth GT2 2mm pitched drive pulley with a 5mm shaft. Make sure you get the right ones. I found some places on Amazon, for example, where they claimed that's what it was and it came back as something completely different. We have 3 bearings that we need. These are all parts in the bill of materials. We have some shims that are used for spacing, and we have a 5mm shaft. Now in my case I bought the 5mm shaft as one long shaft. I have an example here, and it's not ground with a flat on it at the moment. I just cut this to length. I managed to get all 4 out of one piece. This came as 2, relatively inexpensive, off of Amazon, and there's more than enough between the two to do everything you need for the build, probably even 2 builds. These ones I did grind to a flat on them, just with a standard grinder. You can do with this with a bench grinder or a hand cut-off kind of grinder. Either way, the flat doesn't have to be perfect. All it is used for is to make sure that the grub screws, when you tighten them down, are not going to slip around the shaft if you don't have them quite tight enough. That's really all. So when you're assembling this, there are some instructions in the manual telling you exactly how to put them together. So let's just go have a quick look at that. Okay, looking at the assembly, so we've got the plastic parts that we need to put together. These 2 pieces, by the way, are the same part. This is the top, or this is one half. These 2 pieces are the other half. They're just showing different views for the sake of the heat set inserts. So first thing, this is a 60mm long 5mm diameter shaft, which has got a flat ground on it, and we need to add the 20 tooth 9mm wide pulley, and that is, according to this, 33mm from the end of the shaft. So the easiest way to do that is to use some calipers. Set it to 33mm. There's actually an easier way than measuring this that I found to do. So that's roughly 33 there. And then take an Allen key, see if I've got the right one handy. And oh, that's not the right one. Take your Allen wrench and nip it down. Double check your distance. Yep, that's 33. And then you build your other components on top of that. You can see here, this is what we've just put in. So we need a bearing on one end of it. Okay. On the other side, we need a couple of washers. The trick with these is to, if you do have some that are really more like stamped washers than really nice flat shims, keep the rough edges facing each other and have the smooth edges going towards the pulley. Then we're going to put another bearing in. That just slides in. Then we need a couple more shims. So we slide these in. Then we put the big pulley on facing it. Okay, so we have it basically assembled the same as that one. If you want to double check on the diagram, we'll go to that. So we've got our 33, which is our initial measurement. So that was this one, 33 from the end here. Put a washer on, 625 bearing on the end, a couple of M5 shims, another bearing, couple more shims, the big gear, and then another 625 bearing. So we've got 3 bearings and all the rest of the components. This is what it should look like when we're done. So let's go back to the overhead view. So that's what we have. And then what this does is it's going to fit into one of these. Now it'll only fit one way because obviously you've got this big wheel that sits in here. If you look, these bearings need to move out slightly because they have to drop into the grooves that have been set up. Putting Loctite in, you need to make sure you've got the wheel that's got the flat on it. If I can find the flat. Alright, that one flat is up here. So we want our grub screws to be facing a flat. So let's pull this out. Take this grub screw right out, and then we're going to tighten it down by putting a bit of Loctite on it first. We're going to put the tiniest bit of blue Loctite on the end. All you need. And we'll screw that back into here and tighten that down. I've tightened that one up just a little bit, but I haven't put any blue Loctite on yet. What I'm going to do is go to this one while that other one is holding it in place. Pull this one out. Put some Loctite on it. Don't get the red Loctite, that's all extra strong, and you may have a difficult time getting things apart later on. Tighten that one down. Now we'll go back to these two, or this one, because I haven't put any Loctite on it yet. And we'll repeat for the other two, so I won't bother boring you with that. That's all of them done. Now, if you lift it off the bench, you'll find it will spin nicely, but because it does protrude very slightly from the underside, it won't spin on the bench. The way this assembles is this top piece will go over the top here, and it clamps down very nicely. And you're going to be putting some M3 cap head screws right the way through into the heat set inserts that we're going to put on this side. So I'm just going to do one of these right now. I'm not going to go into the depths of heat set inserts. I have a little tool that I'm going to use to help me with it. You find that you can do this with a soldering iron and things like that if you want. These dedicated tips for a soldering iron are very, very cheap these days. I think you can get them for about $7 Canadian, or what, $5 US for a set of them, and they take next to nothing to use. So I'm just going to quickly do the ones for this. For the heat set inserts, we've got 6 to put here, 6 of them, and 1 on the top. And for this one, cap head screws go in from this side. This is the bigger one of the two, but there are 2 heat set inserts on the top here. That's for securing the feet. Now, one of the things you might want to do before you put the heat set inserts in is where the screws go right through, you want to make sure they're clear. If your 3D printed parts are not perfect, sometimes they won't have clearance holes for your M5 screws to go right through, and it's easier to clear them out now than it is once the heat set inserts are in place. So this is the side that's going to have the great big long M3s. They're going to go right through into the heat set inserts on the other side. Okay, they're going to go right through here. But I can feel that there's a little bit of, they're a bit tight. The clearance is 3.4 millimeters for M3. This is a 3.13 millimeter drill. So I'm just going to quickly run this through the holes to make sure that any debris from printing is gone. So I'm just going to put that drill bit into my hand drill. You don't need a lot of torque on it. You don't want to break things. And what I'm going to do is just run it through the holes to make sure that I've got the clearance for the screws. Just nice and gentle. Sorry about the noise. You don't want to make the holes go crooked or anything. Okay, that's all you need, and you may not even need it. Try a screw in the hole first. If it just slides right through, then you're golden. Now the other side, obviously you're going to put the heat set inserts in here. They're for a 5 millimeter. So run the drill from this side of it, just for the last bit, and that way you're going to make sure you get it square in the hole. I'm just going to quickly do this for this one. I'm only going to show you doing one of these. Now obviously this drill is undersized for the actual screws that are going to go in. So that's all of those holes done. Now if I take an M3 screw, it should just drop through nicely in all of those holes now, which it does. Alright, so that was a 3.1 millimeter. Alright, so we put this together. We've got Loctite on all of the screws. The next thing we need to look at here is we need a GT2 188mm belt. So I have some of these on the overhead. So what we're looking at are these. These are 188 teeth, oh sorry, millimeters. A 2mm pitch, 6mm wide, 2 GT type belts. We need to make sure this is the one we're going to assemble, is on here before we start. Now it doesn't look like there's much for putting a pulley on, but believe me, that is more than enough to get the motor in there and tightened down. Now be careful when you're ordering these too, because you will find some that say 200 2GT and things like that too. They won't assemble as well. I mean, technically you could modify some of the prints or space out the motor mount to use it, but you really want to use the 188 2GT. So what I want to show you is putting together the heat set inserts. So I've got both kinds sitting in my hand. I may put a zoomed in image if I can't get these to show up. Take a pair of calipers, and is the length, you can see exactly 4mm, and the diameter is 5mm. If I take the other one that I have here, it's very easy to confuse them when you're ordering them. This one is 6mm long, not 5mm, and it's slightly narrower, 4.58. So if you try to use these, in a lot of cases, if your 3D prints are not perfect, they'll still work okay, especially if they're slightly over extruding. But if you've got your prints dialed in, these might be a little loose for you and might pull out. Alright, so I'm only going to show you using this tool at the moment. This one has a little temperature gauge, and I've dialed it down to almost the lowest setting, 240, because, you know, ABS, melting point and things. This one conveniently has a switch on the side of it too. The way I deal with these is they have a little ridge on one side. They have a zigzag cross pattern on them. One side has a smooth wall. I'm going to put the iron down for a moment. So you can actually sit them into the holes ahead of time. They'll kind of click in a little bit, hopefully. The last ones I tried did. Now if you're trying to use a soldering iron like this, alright, it could work, but it's going to be, you know, this one does, and this one has a magnetic temperature control, so it's going to be like 350, 400 degrees, so it's going to potentially overheat, melt more plastic than you want to. This is a nice round tip on it, but if you've got a conical, a tip with a flat chamfer on it, then that may not work as well. So the preferred tool for most of us now is to use these heat set insert tools. You can find them on Amazon and things like that. Anyway, the way they work is drop your heat set insert into the hole, or get it roughly lined up. Take it vertically. You want to make sure that it is going to go in straight. Sit it in there and then let it warm it up, and then it's going to just drop in, and then you pull it out just as it's gone below the surface slightly. I think there's plenty of videos around the internet about using these, so I'm not going to go into too much detail here, and as I said, I will do a separate video on using the heat set inserts and different techniques. Just right now I want to assemble this piece so I can show you it going together. You can see it goes together pretty quickly. I'm setting these in maybe slightly deep, but that's okay. The threads come in from the other side, so it's only going to serve to pull them in deeper, if anything. Now this one wants one on the end. And that's all of them on here. Now we want a couple of them. One short. I have to grab another one. Just get this one in first. One thing I find very useful, by the way, just as a tip, is when you're building a printer like this, is to try and get some kind of organization. In my case, I've got all my M3x8s here, all my other sizes here. The M3x8s are separate because you go through a boatload, different T-nuts, my other M3 screws. These are all my M5 screws, heat set inserts, all my gears and pulleys and bearings are all in the side here. I have other plastic containers with all the 3D printed parts, etc, etc. Anyway, back to this heat set insert. So I've got one more here. I'm going to just drop that there and we'll heat that in, and that'll be all of the ones for this. That's in there nicely. You don't want to overheat the plastic, that's why I have this dialed right down. This is probably about the cheapest, one of the cheapest soldering irons with the temperature controller on it, except for the little dial ones that I could find. There's no need to have anything expensive. I already have a really good Weller if I want to do actual soldering. This one is about an 80 watt or something, and I've also got a Weller very expensive soldering station for doing all sorts of rework and stuff like that. So this is purely for doing heat set inserts. Now the other end of the pulley mechanism, top idler pulleys. Now these are much simpler. All you have is a 9mm pulley, a M3 nut. Now it just calls for regular nuts, but I like to use these, I call them nylocks. They got a nylon insert in them as well. So the screw, when it goes in, will not shake loose very easily at all. You've got your M3 screw, you've got your idler holder, and you've got your frame that screws onto the main aluminum frame of your machine. So these go together very easily. Just have you put this tightener in here first, because otherwise you're going to have a hard time getting it past the pulley. Take your idler, take your M5 screw, put it right through. Now it's threaded onto the idlers. There are some mods for the Voron that let you use pins in some places, but it's designed to just use this. It screws right through, and it actually calls for cap heads, but in this particular instance I don't have any of this length, and it doesn't matter from a structural perspective whether it's cap head or not. It's just purely cosmetic. I'll just tighten that right through. It threads into the plastic, so you don't need to lam it up. It's unlikely to come loose, so as soon as you run out of thread, like that, that's plenty enough. The idler's got room to move as it's being used, so that's in there now nicely. This piece goes with it. What happens is this is going to screw into the frame of the aluminum, and this is going to sit here. There's a hole where the nut goes. I found the easiest way to deal with that is to put the screw right through, get the nut. What I will do is I'll just screw it all the way in so that it's tight, and then I'll back it right off again so that the idler is the longest. That will become more relevant when we're putting together the belts for the Z drive. Good enough. So you can see there's a reasonable amount of adjustment now for this. And this is going to mount up into the Z frame, into the T slots with a couple of screws to it. They normally use screws like this, and it makes it like very pretty, like eyes kind of look. I don't have any that are long enough. You can see these are a bit shorter. Again, it's only cosmetic, so I have these ones with their cap head. So this will do. This will just go in. It's going to be snug, which is great because you don't want it wobbling around too much. So it comes right through on that side. And we do the same with the other one. Right, both of those are in. So that's basically the Z idler. It's going to screw into the frame on the top inside. We'll see when we get to that. I'll show you. So that's the idler basically completely assembled there. Going back to the main pulley, don't forget when you're putting it together to put the belt over. Drop it in, get all your bearings dropping into their perspective slots. I think a couple of my 60mm shafts are about 58mm, but that's still long enough to make this all fit together properly. The top piece will just drop over it, and basically just run all of your M3 screws through. So let me just grab them. Now we're putting the top piece on and we're dropping through the 6 M3x40 socket head screws. See, they slide through nicely. Should probably get myself a little electric screwdriver for this. It would make life a bit easier. Now when you're tightening these, you can see it's just got to the surface here. Right, just a little nip and that's all, because it's going to pull those heat sets in towards itself. And then just work your way around all of them. I don't think, some people will put Loctite on here. I don't think it's necessary for these screws. They're going into brass with steel. They're going to pretty much lock themselves up anyway. You can see these are getting in quite nice and easily. Not hearing any branching or anything like that. Alright, that's that on. And you can see it still spins nice and freely, which is perfect. And now this top piece is for a foot to go on to. And here we have another opportunity for embellishment. So I've got white or black with my foot mount on there. This sits on top. Got to put an M5 nut in there as well. And then M3x8 screws, which are these. Alright, so you can use this kind of M5 screw, nut that I prefer to use. You can get skinnier ones and fat ones. I prefer the skinnier ones here and the fat ones. And we need the 3 M5. So on the back of there, it's got a place set aside for the nut to go in. It should click in. You may need to put a little spot of super glue in there if it isn't a tight fit. Some glue here somewhere. See, I've mounted this. We've got to get this 10.7 from the main body of this. So set my calipers to 10.7. You can see I've got a bit further to go because this 10.7 is to the flange, bottom flange. I actually got this pulley the other way around, but I have enough length that I can mount it either way as long as I can get this part here. As long as I can get this part of the pulley 10.7 from the flat of the body, that's what matters. You can see right now it's slightly longer, slightly further out than it needs to be. So we'll measure this. Now when I put this together with the belt, I'll show you another way that you probably have to tweak it at the end of the day anyway. So I'm holding that at 10.7. Tighten that up, double check that. That's looking about right. Yeah, I know my caliper shifted slightly, but it's only a fraction of a millimeter. So I'm not going to Loctite these down yet. I will tighten it up a little bit, just so it doesn't move. But I want to get a final position once it's assembled and it's connecting to the GT belt from this. Because when this is joined together, so that's going to be like this. This is going to be here, like this. So you're going to need to make sure that when all this is together, that these two run nicely to each other. Alright, so if there is any discrepancy in the assembly of this, now they do have notches on the bottom to make sure everything lines up in the 2020 slots on the extrusions, and of course you're screwing in as well. This is down one angle, this is down the other side. They're 90 degrees to each other, they're right in the corner. So you want to make sure that this is running down the middle of both of them. So once it's assembled, you may be able to just slacken these two off, rotate the belt a little bit, and then when it'll find its own center, then you can just nip them up, put some Loctite on them. And when you tighten this up, you'll see as you tighten it, it'll push it away, you see? That's what that does. So this one is now assembled. As I said, I haven't put Loctite on there yet for that exact reason. And we have the main gearbox assembled, and we have our Z idler assembled. So let me just put the rest of those together, and then we'll go to look at putting it on the frame. So I will catch you in the next video where we will assemble the Z components onto the frame. See you then.